Alright class, so today we learned about scientific notation. We learned how to take numbers from standard notation to scientific notation, and we also learned how to take numbers from scientific notation back to standard notation. As you can see on your homework, you have two different sections here. One is going from standard notation to scientific, and the other is going from scientific back to standard. And I'm not going to do all these problems today, but I'm just going to do a couple of each, so I'll probably do 4 on each side. I'm going to do 2 really big numbers, so I've decided I'm going to do number 1 and I'm going to do number 9. And then I'm also going to do 2 really small numbers. I'm going to do number 3 and I'm going to do number 7. Okay, that way you can see a couple examples of some really big numbers and a couple examples of some really small numbers. Okay, and one thing that I really want you to focus on is that when we have a really big number, okay, we're going to have a positive exponent. Okay, and so that's something maybe you want to write down. Like I might write it down here. If I have a big number, that's going to be a positive exponent. And if I have a small number, that is going to be a negative exponent. Okay, and so the first thing I want to do, we'll start with number 1. The first thing I want to do is I want to find my decimal place. Now, with really small numbers, you can already see that we have our decimal place. But with really big numbers, there's not a decimal place there. And so what you have to do is you have to put your decimal place there. And for really big numbers, it's very easy. The decimal place is always at the end of the number. Okay, and so I've identified my decimal point. And now I have to move my decimal point to a stopping point where I have a term that is at least 1 but greater than 10. So I'm going to take my decimal place and I'm going to move it, and I'm going to continue to move it along each number until I get to a place, which in this case is right here, where I get a number that is at least 1 but no more, or excuse me, at least 1 but less than 10. Okay, so 10 is not included in that number, so I could have any range of numbers from 1 to 9.99 repeating, but I cannot have 10. So it's any number that is at least 1 but less than 10. Okay, and so this case it's 3.07 is where I stopped my decimal at. So right here I stopped my decimal. I have 3.07, and 3.07 is in fact between 1 and 10. It's at least 1. But less than 10. Okay? So then after the 3.07, I always do times 10 when I'm doing scientific notation, just like you see over here. Okay? And then for my exponent, I have a really big number. So with a big number, I'm going to have a positive exponent. And to figure out what my exponent is, I'm simply going to count how many spaces I had to move in order to get this first factor. Okay? And so I'm going to count 1, 2, 3, 4, 5, 6, 7, 8. And so taking 307 million to scientific notation would be written as 3.07 times 10 to the 8th power. Okay? All right, I'm going to do number 9 now, the other really big number. Okay, so I'm going to once again put my decimal point on the end. And once again, I'm going to move until I reach a term that is at least 1 but less than 10. Okay, and so I've got my term being 9.461. Okay, and that is definitely at least 1 but less than 10. And then I'm going to multiply that by 10. Okay, and now I'm going to count to figure out what my exponent is going to be. This is a really big number, so I'm going to have a positive exponent. So I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this would be 9.461 times 10 to the 12th power. And the great thing about this, guys, is you can check this in your calculator. Okay, so I can do, for example, this one, 3.07 times 10. Remember, to get an exponent that is greater than 2, we must hit this arrow here underneath the clear button, and then we push 8 in this case, and that gives me 307 million. Okay, we can also check this one, 9.461 times 10 to the 12th power. Okay, and now look what happens here. So if you notice in this first one, we got the exact answer that we saw. Okay, but you see how big this number is. It's a pretty big number. It fills up over half the calculator. Okay, here, this is a really, really big number, right? To actually have this whole number out on the calculator. Okay, the calculator's not programmed to do. Let's see if we could do to the 9th power. Let's go ahead and test and see kind of how far we can go out with it. So if I did the 9th power, okay, that's good. Let's see if I go to the 10th power, times 10 to the 10th power. Okay, so once you get to the 10th power, okay, you're going to get this E symbol. Okay, so notice if I go back up, right here we were at the 12th power. Okay, so once you get to the 10th power, you're going to get this E, and then you're going to get your exponent. And that means that E means times 10. And basically what the calculator is telling you is that it's too big of a number to be able to put on the screen here. Okay, same thing goes when you're doing a negative exponent. The lowest you can go is to the negative 3rd power. So for example, if I had, let's clear some of this out here. If I had this 3.07 times 10 to the negative 3rd power, it would show me what my decimal is. But if I did it to the, whoops, back here. If I did it to the negative 4th power, you would see that I get that E again. Okay, so those are your limits. Okay, so your limits to checking it in the calculator, if it has an exponent that is between negative 3 and positive 9, okay, including those numbers, okay, then you can check it in the calculator. If it has an exponent that is negative 4 or smaller, okay, so negative 4, negative 5, negative 6, so on and so forth, or if it has an exponent that is 10 or higher, so like to the 10th power, 11th power, 12th power, then you're going to get this in your calculator. Okay, so anything that has those exponents that is 4 or less or 10 or more, okay, you won't be able to check it in the calculator. But anything in between there, so an exponent of negative 3, negative 2, negative 1, an exponent of 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9, you would all be able to input in the calculator and double check your work. Okay? All right, so let's go to number 3. We have a really small number, so a really small number, I'm going to have a negative exponent. And once again, I'm going to start from my decimal place, and I'm going to move until I get to a term that is at least 1, but less than 10. And I get to there right here at 8.29. So I'm going to write 8.29 times 10. And let's see how much we moved. 1, 2, 3, 4, 5. But remember, it is a really small number, and with a really small number, we have a negative exponent. So this would be 8.29 times 10 to the negative 5. Once again, this is smaller than negative 3, so if I did try to check it in the calculator, it simply would not compute it. It would give me that E. Okay? But let's say it was to the negative 3 or greater, then it would work. Okay, so that's the limit, okay, to where the calculator works for you. Okay, let's try this one, number 7. Number 7, once again, I'm going to start at the decimal, and I'm going to move until I get here. So 7 is definitely at least 1, but less than 10. So I get 7 times 10, and I moved 1, 2, 3, 4, 5, 6. And it's a really small number, so my exponent will be negative. Okay? And once again, I'm not able to check that one because it is to the negative 6th power, and in my calculator, I will get that E symbol. Okay? But you know from what we did in class and from following my example here that this is the correct answer. Okay? And so those are 4 examples for you going from standard notation to scientific. Now we're going to do some examples going from scientific back to standard. Okay? And if you notice here, we kind of have the same situation on number 1. Right, number 1, you have that negative 6th power, so you can't check that in the calculator. You're going to have to only do that by hand, because if I try to type this into the calculator, once again, it will give me that E symbol and not the answer that I want. Putting down this answer right here is not acceptable. Okay, I want to see the actual standard notation. This is not standard notation. Okay, but like for example number 2, right, I could definitely do that one in my calculator. 9.9 times 10 to the negative 2, right, that would give me 0.099. And if we look at the process, you would take 9.9 and you would move it to the left, because we know negative exponents, we have a really small number, right? And so 0.099, okay, is a very small number, okay, and we know that's going to be a small number because it's a negative exponent. Okay, so I did number 2 for you. All right, let's do number 7, and we will do, let's do number 4, and we'll do number 1 since we kind of already talked about it. Okay, so number 1, I have 1.045. Okay, and I don't have a lot of room right here, so I'm just going to kind of scoot up and write it up here. 1.045. Okay, and I've got to do it to the negative 6th power. So I know I'm going to have a really small number, so I'm going to move this many spaces. 1, 2, 3, 4, 5, 6. So I have my new decimal point, and I've got 1, 2, 3, 4, 5 zeros. So this is point 1, 2, 3, 4, 5 zeros, and then 1, 0, 4, 5. Okay, so you've seen 2 really small numbers. Okay, and you've seen that the negative exponents make small numbers. Now you're going to see the positive exponents make the big numbers. So here I have 2.36 times 10 to the 5th power. I could definitely enter that in my calculator, and that would give me 236,000. Okay, but if I did it here as 2.36, I move 5 to the right, and I add those 3 zeros, and that's how I get 236,000. Remember, positive exponents, we have a really big number. 236,000 is a pretty big number. Okay, negative exponents, once again, we have these small numbers or these decimals. Okay, here we go, 2.345 times 10 to the 11th. Now this one, remember, you can't do in the calculator because it is over an exponent of 10. See, if I try to do it, I'm going to get that E symbol. Right, and remember, this is not acceptable for standard notation. Okay, so here I'm going to do 2.345, and I've got to move it 11 spaces. Okay, and I'm going to move it to the right because I know it's going to be really big numbers. So 3, 4, 5, 6, 7, 8, 9, 10, 11. Right, so I've got 1, 2, 3, 4, 5, 6, 7, 8 zeros. Okay, so if I write this number here, it's going to be 2, 3, 4, 5, and 8 zeros. 4, 5, 6, 7, 8. And every 3 zeros I will put a comma. Or every 3 numbers, rather. Okay, so this would be 234,500,000,000. Okay, and so now you have had some examples going from standard notation to scientific, and then once again going from scientific back to standard. This will be on your STAR test, okay? And remember that your parameters here for checking this in the calculator are an exponent. It's going to be between the negative 3rd and the 10th power. Okay, once you get to the negative 4 in the exponent, or once you get to the 10 in the exponent, okay, the calculator is no longer going to help you. So you do have to know how to do this without the calculator. Okay, but the majority of the time, hopefully, on your STAR test problems, you'll have ones that you can put in the calculator, which will hopefully make it much easier for you. All right. This is Scientific Notation. Mr. E signing off. Have a nice weekend.